I have a voice that's just loud enough in the meantime anyways, that it kind of works. So there you go. There you go. Yeah, I told you, it's magical. Feel free to take a seat, get comfortable. Not complain to tutors too much. Just kidding. Right, well, first of all, I'm waiting to see whether there's a hand up as to whether we're live and we're saying hello to the world on YouTube and so on and so forth. I'll assume that this is the case. All right. It doesn't work as the mic. Like the mic, I know when it works back. Like YouTube is a bit more of a mystery. Like, has YouTube started? Is it good? All right. Let's get going. First of all, big welcome to these Infra Masters in London and online for anyone who's following online. We're also going to organize some around the globe. We have planned some in Spain, Italy, Australia, Brazil. So if you're missing out on the physical experience, wherever you are in the world, just get in touch. We'll organize something. And the goal of these events is fairly straightforward, is to get to understand the best in infra transformation from the best in the market. No pressure for the presenters there. I can see them. There's a very subtle hint. If you see someone at the front in orange, they're from Canonical. If you see someone at the front not in orange, they're not from Canonical. I'm sure everyone will notice the subtlety of the orange as well. So off you go. On this note, you're not here to see me, but you're here to see James, Curtis, and Ali, who will be presenting. James and Curtis from BT, the floor is yours.
Come on, stand in the middle.
Oh, we're standing in the middle, are we?
Yeah.
Yeah, hi. So we've got the best slot before the guy that talks about rockets. So, yeah, so I'm James from BT. This is Curtis.
Yep. So I'll introduce James. So James is our principal engineer. So he works within cloud services. I've known James about 4 years now, is it, James?
A little bit longer than that. But
Well, yeah, as we've worked together.
Feels much
for 4
longer.
years. A lot longer. So we have a close relationship, and we get a technical feed in from James. And then it's turned into our engineering team to actually deliver.
So Curtis is one of my colleagues. There's some more sitting in the front. They'll be mingling around at the end. So Curtis heads up some of the engineering teams, and as he says, he takes what we need from requirements around the business, from our customers, and then his teams and his colleagues deliver it. So I'll start off with running through why we started talking to Canonical in the first instance, what our challenges were. So we needed a solution that was highly dependable, so that, well, we needed to rely on it. It's not just running anything. It's running some of our core network applications. And because of that, because of the workload that it's running, we needed it to be highly performant. It's not just running sort of anything. We'll run through in a little bit some of what it's doing. I'll leave the suspense. So with the workloads that it's running, it's forever increasing as well. It's not a static workload. The sort of workloads that we're running on it, our customers are always asking for more and more, but they don't want to pay for more and more. So we needed something that we could grow, something we could get contributions to, and just something that we could rely on. So because of that, not only did it need to work, not did we need to rely on it, we need to be able to monitor it. So we need to be able to integrate the high integrations of monitoring capabilities to ensure compliance and to make sure it was working, to make sure our customers could rely on it. So the question I often get asked to start with is, why didn't we go to public cloud? Why did we do this on-premise? Why did we build our own infrastructure? So I'm not a fan of this picture, but I'm going to talk through it. So basically, it's down to the workload. So we've got very run-heavy applications. So what we've found, public cloud works really well when you want that very fast feedback around development, so the early stages of that application development. But once they become run-heavy, once they're there performing constantly at a high level the whole time, we found that the infrastructure, the open source solution that we've gone with, works a lot better. So why do we choose open source? Why didn't we buy a solution? Why didn't we buy a packaged application to do this? We needed something that was, as I said, highly flexible, highly performant, but also integrates with a lot of systems. As you can imagine, at BT, we've been around for quite a while. We've got a lot of legacy stuff. So we needed something that we could integrate in to other parts of the business, but also maintaining the services that run, integrate into the observability stuff, but also move into sort of some of our consultancy stuff that we needed to work with Canonical in order to make this work. So we needed something that could evolve. We built this, we started with Network Cloud in 2019, just before. So it's not the same now as it was then, but I'll go through that on the next slide. So what's the solution that we worked with? We've taken majority of the stack from Canonical. We make use of MAS, which is our bare metal or metal as a service. So that provisions our infrastructure for us. The bit that often surprises people is we've got Ceph in the mix. So that's one of our key storage solutions. It's not the only one. So one of the benefits that we have found by using open source is the amount of integration we can work with. So we don't have to keep it limited to just the solution that we've got. So we can integrate into other storage partners. We can integrate with other operating systems either. But we won't mention those ones today. We make use of LXD. So LXD, as we refer to it, gives us capabilities to run other services within the cloud. But predominantly what we're running is virtual machines. We make use of Juju as well. So Juju takes care of bringing it all together, applying the configuration that we need, and turning it into the end solution, almost. So what we've also managed to do is integrate a number of our own tools, our own automation, to take it to the next step, to really drive that performance and turn it into what we really needed. So what was the outcome? How did it work out? As I say, we worked on this, we started work on this about 5 years ago, and it's worked well. So it took us from a number of what would have been proprietary stacks, all needing their own monitoring, observability, authentication, compliance. But we managed to bring all that together and turn that into a single stack, which we refer to in BT as Network Cloud. And it allows our app developers to focus solely on their application development. It means that we as the infrastructure team have been able to focus on making the infrastructure work. They've been able to focus on making the application work. So I mentioned earlier, it's not the same as what it was when we started. People often say to me, okay, well, you've got it working, you must have a massive team. I think from an infrastructure perspective, we've got 50 people working on it. Might sound a lot, but in the grand scheme of how big BT is, it's not a lot of people. They say, okay, well, it must be consistent then. You must never have changed anything. We have. We've changed so much. We've swapped out major hardware components. I mentioned we won't talk about other OSs today, but there are other ones out there. We've integrated those fully into the stack. We've swapped out our entire SDN layer. That was no mean feat. All of this has been with the support of Canonical as a partner. So I said that I was going to mention what's running on it. The suspense is over. We're not just running anything on there. I titled the slide, Powering the UK by Open Source, because that's really what we're doing. If you are a BT or an EE customer, if the guys online, or guys and girls online, are streaming this via a BT product, you're actually streaming it over this solution. So we're powering the mobile network, we're powering broadband, we've got security solutions on there, we've got voice, we've got global connectivity. So many of BT products now rely on this solution that we've built with Canonical. And that's something that we're proud of. And it's something that has been noticed. So probably get sick of seeing our adverts on TV. But we've maintained #1 network, I think 11 or more years now. I can never quite remember. And the bit that we're probably most proud of is we've maintained that whilst moving the whole of the UK's, or the EE 5G core onto an open source solution. We also got the highest score that we've ever had whilst doing it. A little bit more local to our team. This is a lot of us, not all of us. We were identified with, or noticed, we won the award with Computing Magazine for the Cloud Excellence Award. That was fun. We had a good time there. We were really proud of it. But it wasn't just us. Canonical were there with us as well along the way. We shared the success. Because for us, Canonical are more than just a vendor. But I'm going to hand over to Curtis now to talk a little bit more about that.
Thank you very much, James.
There you go,
So, vendors partnerships. So I think one of the things that sort of still haunts us, it's still seen as being a bit of an ex-government kind of organisation, and I think there's always that temptation that we would operate in a very heavy corporate way, and that would change the way in which we work with our vendors. So we could have gone for other vendors. But the interesting point is that BT's actually got a history in massive innovation. You know, you've only got to look at the volume of patents that the actual company owns from our sort of longer given history. So why would we change the way in which we do it? It's actually changing the way we work in partnership with our vendors. So it's not just that usual relationship. It's built on actually working on a single goal together and that reliance. So I'm just going to introduce Ali, and Ali's going to talk from a Canonical side.
Thank you. Thank you so much. I actually don't need this. I have no slides other than this one. So my name is Aliona. I'm on the customer success team here at Canonical. And if you're not familiar with what customer success is, essentially, simply put, we care about the customer-business relationship. If our engineers care that your tech works and is secure, then we really care that the customer is being listened to, that your goals are acknowledged, and that we're all aligned. And over the last 2 years working with BT, it's been amazing to see, and it's a testament to both teams really, the Canonical account team and the amazing BT team, that we've gone from this vendor-supplier relationship and moved to a partnership. And it didn't happen overnight. Nope. And it happened incrementally over time, and we built relationships and trust, and built the communication, more open lines of communication together. So I'm not exaggerating when I say that you really don't hold back on your feedback to Canonical. And we try to listen and tweak and adjust our approach. So we'll talk a little bit more on that as well.
Yeah, good. And I think that sort of segues really well into looking at what the difference is. So in terms of sort of a vendor versus a partnership, so when we look at the actual scope of the project that we run, so often what we see is a very narrow approach. It's all done on sort of statement of works, thou shalt do this, and if there's not, we want some money back, and all that kind of business. Or we can work on a much broader perspective, as in, actually, Canonical know what we need to do and what we intend to do moving forward, which is very different. So our focus, so traditional vendorship relationship, it's all like, can we hammer them down on price? Can we get service credits back if they don't do something right? You know, again, everybody knows how that one works. Whereas actually a partnership is based on value. What are you bringing to us and what can we offer in return? And I guess today's about a return. It's us working in partnership and working with Canonical rather than as just, what can we get out of this? So communication. So instead of very transactional, we ask, you do. This is actually a collaborative way of working. So it's, you know, can I get some feedback? Ali's always ringing me up and, you know, can we sort out the roadmaps? Can we look at what the next training bump's going to be? Can we change what the agenda's going to be? And that's a much more collaborative way of working. So a commitment, very much so, as James has alluded to, this is a long-term relationship, not short-term transactional. This is actually looking sort of more into the future rather than that, what's in the next 6 months. And goals, it's really, really simple for us. So it's not individual goals, it's actually a combined goal of what do we need to do together. So a recent Deloitte survey found that 80% of executives believe that partnerships are essential for growth, for increasing value, but only 42% feel that they're actually managing them effectively. I think that's quite telling. So, obviously much, much more on top of that. So, exploring the partnerships, and I think this is just to reiterate, it's the collaborative approach, working together, working on shared goals, mutual success, so that's holding each other up, value-driven, so it's on innovation, not actually how much money we can extract or give, as it were. Open communications, and as Ali said, our 360 feedback, yeah, it works. We're very honest. And long-term commitment, so it's about looking for that next stage, what's next, what's the future, building those roadmaps out together. So, yeah, a bit of an example, a telecommunications company co-developing a software-defined network solution with open source software company. Sound familiar? So, yeah, that's us. So, what's the foundation of success? Accountability from both parts. So all this is dual. Reliability. So yeah, we depend on this. It's our critical national infrastructure. So 360 feedback, super important. Acknowledging mistakes. And that comes from both sides, and we're really clear on that. When we make a mistake, when you guys make a mistake, you know, it's not used as obtaining service credits again. It's used as a, what can we learn from this? How can we move forward? Shared focus, combined goals, consistency, and we're really, so my team run the automation team, so consistency is key for us, and the approach actually to our relationship is consistent. And transparency. So I think we're going to have a little chat now, aren't we, in terms of what this actually means sort of for our relationship and how we work. So I guess the first thing is, so there's if you think about the open market in terms of training and development, it comes with a cost. So often that's classroom-based, and we don't look at actually what the cost is in terms of monetary cost to invoke training. We actually look at the time our engineers spend doing that. A week's engineering team across, you know, sort of 25 engineers, that's a lot of man-hours lost. So we talked to Canonical about this. We said, you know, how can we work this through? So if you want to tell us.
Yeah, and I remember the first time we did this, we had a whole day of knowledge sharing presentations, and the audience was very wide, and we were not as targeted as we really needed to be. So after speaking to you guys at BT, we decided to break this down into monthly sessions, and you fine-tuned the audience on your side. So the engineers really cared and really used about the product that we were presenting on. And the result was pretty good. We saw an increase in engagement in the sessions, and I think that is kind of the key value driver there.
Absolutely, yeah. So we see we now call them ninja sessions. Yeah. So we run them much more regular, and it's key for us as well is information retention. So like anything that you get when you attend sort of training or development courses is that, you know, we flood you with information for a week and then you go away and never use it. So actually what we try and do is sync up our ninja sessions to when we're doing something, so it actually stays relevant and on the job at the time. So that's one, guys. Let me think. Business reviews.
Exactly. I was going to say that the latest example of the 360 feedback. So if you're not familiar with a QBR, it's a quarterly business review, and at Canonical, it's a process that we simply have to do. And the content is
52 pages.
That was the issue. So there is retrospective content and forward-looking content. So what we've decided from getting together and talking about this is that we have frequent enough touch points with BT that we can cover the retrospective content in those touch points, in those meetings, and really spend a face-to-face time talking about the next steps.
Growth, the future.
Exactly.
Yeah. Yeah,
So
and I think it's that retrospective view in a traditional vendor relationship is often used as leverage, and I think this is about actually how we move forward. So we've I just piped up one day and said, do we really need to do this? You know, sat there watching 52 slides. Didn't go down well, but yeah, we've worked out, and that time's used far more efficiently now actually to look how we move forward rather than actually, we don't need to review, you know, what's been going off. We're fully aware of what's been going off. And it's nice to see if we can work on sort of more day-to-day things that we actually need, sort of creating new roadmaps, what we need, sort of feedback again. So I guess, right, so what's the foundation of success then? So for me, it is honesty and trust. And that's something we definitely have with Canonical. And that's it. Thank you very much.
Thank you.
I think it's back to you now.
Yeah, just to finish wrapping up.
I
So-
should have added on, it's not rocket science, shouldn't I? That would be brilliant.
So the final bit, just to finish off from us, is where next? I said that we've evolved a lot from where we started. We're continuing to grow. So we've got a huge amount of infrastructure now that we need to continue to now optimize, continue to make more efficient, continue to put more traffic on the same infrastructure that's there. That's the bit that Canonical, they like building stuff. You like coming up with new ideas. We want to make use of what's there. But as Curtis and Ali have just talked about, that you're there with us all along the way on that. So some of the areas that we're looking at, continuing to now work with edge compute. Can we get infrastructure closer to the edge of our network than it already is to help with things like 5G applications? I can't really start this week without mentioning containers, can I? So I mentioned already, most of our workload is sort of VM-based at the moment, virtual machines. But a lot of the applications are containerized. So how can we better optimize the infrastructure to support the containerized applications? Are all of our applications right to be containerized? Because subject to, or against common belief, not everything should be a container. And then finally, we talked about public cloud. How can we offer some of the serverless computing capabilities to those app developers to help with that development feedback cycle on this infrastructure without having to go through the pain and the overhead of running virtual machines or full clusters dedicated to themselves? So some of the stuff that we're looking at, not everything. We'll be working with Canonical all the way through this. But that's it from us, I think. Hopefully we're not too ahead of schedule. Yep. But thank you for listening.
As we are a bit ahead of schedule, how about doing a quick Q&A? Any question for Curtis and James?
No.
Hey, we don't have mics. Go ahead.
How far in advance do you guys share your plans? How big of a roadmap do you guys set?
To be fair, years. So we know roughly where the market's going. We know what products and services we need to deliver. So we look sometimes months, sometimes years. It really depends on where we're taking the product in the market, really. But we work with Canonical, give them as much notice ahead of that as possible, and our other partners. So, yeah.
We're fortunate, in fact, we get early sight from our internal tenants, so they might have a specific requirement, the sort of a feature request, as it were, and we can then look at inserting that as part of a roadmap. So some of that is we may need to ask Canonical to speed up some of their development on their roadmap, or it may be a case of it comes just in time as actually where we need it.
So if there's any sort of contribution back into the open source community, that's where we rely on our partnership with Canonical. BT, as a sort of company, hasn't got that big of a reputation in the open source community, I think it's fair to say. But we contribute a lot, we believe, via the partnership with Canonical.
Hi. How do you work out your support? Like, you've got a massive estate there, a national estate. Do you rely on Canonical to be your tier 3 and that sort of arrangement?
Could you repeat the question just
Sorry.
for the online audience, because it doesn't look like the mic is working.
Okay. So the question was, do we rely on Canonical for sort of tier 3 support? How do we? Yeah. So obviously, I didn't go in all the detail on the full stack. There's lots involved in the full stack. So we work with Canonical as one of the support vendors. We do a lot of it ourselves. We've got internal support desks, as you'd imagine. If there's things which aren't working as we'd expect, then that's where we can rely on Canonical. Obviously, they work with not just us, so they've got that visibility of if other companies are seeing something similar. But to answer the question simply, yes, we rely on Canonical when we need that additional support from what we can sort of work on in-house.
And again, it's slightly different in terms of the solution we might have with another vendor is the fact that myself and Kirsty, our teams are almost dognated to actually, they want to try and solve the problem. And one of the things that Canonical always remind us is don't forget our engineers are there to support you. And it's not just a straight, we'll fix it for you. We'll actually show you how to fix it. So it's a great relationship there as well in terms of actually upskilling. And our sort of previous boss always said he'd like our team to be as good as the vendor.
Sorry, can you?
Do you mind taking the microphone?
Yeah.
Is it?
I think it should be.
Oh, the microphone's gone. All right.
Okay.
I just asked about the TSA complaint for the telcos when you host the VNF and CNF.
Yeah.
How it's protected with the open source.
So just for online, the question was around the Telecom Security Act and how we comply to that. So obviously I'm not going to go into loads of detail on that. We can have a chat over beer in a bit. But this solution has enabled us to be TSA compliant. Have to say that because it's the 31st of March. No, in all seriousness, we've been able to adapt the solution. That's where some of the flexibility has been like paramount to that. So we've been able to adapt the solution, introduce new bits, introduce different software from different vendors, configure it in such a way that has meant that we've been able to work around the TSAs. But let's have a little bit more of a chat later on that one, if that's all right.
I'm very worried about the lack of microphone because Michael needs a microphone afterwards to present. So, you have one
We
there?
have one here.
All right. In which case, just to be back on time, there'll be time for more questions later. So, and I'm sure you'll be here around.
As I say, we've got a wider team here as well. So, yeah, you can talk to us all.
On this note, thanks a lot.
Thank you.
Thank you very much.
Michael, here we go. Michael from ESA.
Thank you very much. Just to test, you can hear me okay? At the back? All good? Yes? Super. Hi, yes, thank you. Good afternoon. Thank you very much for having me. I'm delighted to be here today to give a presentation about the European Space Agency, because I'm not sure how much everyone knows about it, and also about what we're doing in terms of IT infrastructure at our Space Operations Center in Darmstadt in Germany. So yeah, I work in the mission operations IT infrastructure in Darmstadt, so that's my area, my domain. But first I'll give an overview of ESA. Super, that's working. So yeah, ESA is now celebrating its 50th anniversary. It was founded in 1975 and committed to the peaceful exploration of space. So we have 23 member states, 3 associate members for cooperating agreements, and Canada as well also takes part in some programs under a very long-standing cooperation agreement. It's worth noting that ESA and the EU are separate organizations, but we work together very closely for the benefit of all European citizens. And of course, the UK there is still a full member of ESA and was one of the founding members at the start, one of the original 10 founding members. So unlike many other national space agencies, ESA covers all of the aspects of space activities in terms of space science, human spaceflight, exploration, Earth observation, space transportation, navigation, operations, and space safety, which I'll come on to in a moment, plus active industrial development. So this makes ESA very unique. We have independent access to space and also a deep space antenna network called S-Track. Give a brief overview of some of the missions that ESA has been involved in. So our solar system explorers investigating a planetary neighborhood, tackling big questions to help put Earth in context, to understand a planet's interaction with its host star, and searching for habitable worlds. And we have our fleet of cosmic observers that's investigating the universe across the electromagnetic spectrum. Some of these missions have been going on for a long time now. I think XMM is on here. Still going since 1999, 25 years, and still working. Yeah, we're looking at the universe from its early beginnings, the exoplanets, stars, and the galaxies that we observe today. Yeah, the International Space Station is one of the world's greatest cooperative projects in science and technology. Half of its living space was actually built in Europe, and ESA astronauts regularly stay on board for 6 months periods, performing research projects that underpin advancements in medicine, material science, and many other areas, and conduct educational activities to help encourage millions of students to study STEM subjects. Yeah, ESA is also part of an international team building humankind's most distant planned outpost, the Lunar Gateway, a spaceport that will orbit the Moon as a base camp for lunar exploration and a step on the road to Mars. There are 130 million pieces of space debris larger than a millimeter in orbit around Earth, threatening satellites now and in the future. ESA started a Zero Debris Charter, aiming towards an ambitious collective action on space debris mitigation with the goal of achieving a zero debris future by 2030. We also have the ESA Space Weather Service, providing timely and accurate information to enable mitigation of the adverse impacts of space weather. And our planetary defense helps in searching for risky asteroids and predicting their orbits, and producing impact warnings and suggesting potential ways of mitigating them. For example, the kinetic impact, you may have heard of the DART missions from NASA, and then we have HERA, which was launched last year. That is now on its way to go and have a look and see what happened. There's only so much information you can get from telescopes from Earth. Easiest is to go and have a close-up look, and we have small CubeSats coming off this to take a close look at what happened with that mission. So over to Darmstadt in Germany. Once the launcher has done its job and a new satellite has been delivered into orbit, this is when the main control room in the ESOC, in the European Space Operations Centre, take control. That's when we can cheer when we have separation and we get the signal, we have a mission. That's when we can start cheering. Every mission is supported by a big team, flight control team, specialists in ground stations, flight dynamics, mission analysis, software and systems. And at any one time, these teams are looking after some 20 to 25 spacecraft, 24 hours a day, 7 days a week. And yeah, as we are flying more complex and ambitious missions, including planetary defense, this is going to get even more complicated. Which brings me nicely on to, I'd like to tell you a bit more about our IT infrastructure evolution that we've had in Darmstadt in ESOC. So first, back to into the past, our original legacy missions. This is where we would have, as always, the software would be developed, it would be deployed onto the operating system, running directly on the bare metal, and everything was tightly coupled. So if you wanted to replace that hardware at some point, you are a bit limited if you can't also update your OS, because then your servers may not be supported anymore, which for most is probably not a problem, but at SOC we're quite a bit more risk averse than the other sites, because here you have a mission, anything you might tweak here on in the control room might have an impact on the ability to communicate with that spacecraft. So you will have missions where you are using hardware which can be very, very old. I don't know if any of you remember Rosetta, it was the comet chaser. I mean, that took 10 years just to get to the comet. In that time it was in hibernation, and 10 years to develop the thing to get to that point. So we had hardware which was also that old. I can imagine 20-year-old hardware trying to find replacement parts when they break is not much fun. Then we had the usual case of pets versus cattle. I'm sure you're probably familiar with that concept, yeah. So you had servers with nice names, and we looked after them. If they start working, then it would be really hard to rebuild them. We'd have meetings to understand why they went wrong. So as you can see, this was not really sustainable. We then continued in our journey. We moved to the virtualization, as many have already done. So here, it made it much easier for us then to replace the bare metal server, because the VMs were now virtualized. So it took that pain away. XMM, as I mentioned, is 25 years old. That is now running in this virtualized platform, so we can keep it going. In fact, actually, the mission operations are very much automated, so it means we can reduce the costs of keeping the mission going, and that helps us to extend its lifetime as well. So as long as it's giving us useful scientific data, and we can keep the costs down, then we keep the mission going as long as we can. Yeah, so of course, with it being running on a virtualization platform, if a blade would fail, then it would be restarted elsewhere on another blade, so you have the live migration. But of course, you have the same problem that, of course, as it's a lift and shift, it's just moving your software just onto this platform. Everyone will notice if suddenly your mission control system just went down and you have to start somewhere else. Fortunately, it's not so critical. You don't have to have always contact all the time. So we do have tolerance for not being able to send any commands, but still, it's not optimum. Also on this platform, we were able to then get a bit more efficiency. So instead of having a lot of wastage where each mission having its own even database servers and all the wasted space on there, you can start bringing everything together. But ultimately, we started to get to the limits of what we could do, and as we needed to increase the number of missions that we're supporting, we needed a way of being able to scale this a bit more effectively. So that's when we started to embark on our cloud-native journey, as many of us have done in that time. So here we can get a bit more resilience at the software level as well, so we can have more high availability. So if a blade goes down, then hopefully Kubernetes will then start to restart those pods elsewhere, but there's enough other replicas running such that worst case you get degraded service, but the mission can keep on going. We can automate the deployments. That was for us then the key benefit here, to be able to just automate the infrastructure deployment and automate the deployment of all the software needed for those missions as well. So there's not only more missions coming, there's also a lot more data being generated. So at SOC, we're interested in what's called the housekeeping data. So that's the health of the spacecraft, so and not the actual science data that actually goes to ESAC, to a different site in Spain. So with all that increasing amount of data, and of course the advent of AI, we needed a way to be able to start bringing everything a bit more together. So that's why we have worked on having Kubernetes deployments, also backed by Ceph. Later on, we're talking about this as well. We have now Kubeflow and Spark also deployed to one of our clusters as well. So we are, though, a small team, which I'm working in. We certainly don't have the know-how to get all of this up and running. So this is why it's very important for us to turn to industry partners to be able to say, okay, who can support us with this in our journey here? And for sure, 24/7, 7 days a week service is needed. And here we can get the support as well all the time with active monitoring of our setup. So that's really appreciated. What we do for time? So I'll give a short overview of how AI is helping us to support mission operations. Yeah, this comes from my colleague. If you want to see the full story, this is also on YouTube, I believe. So yeah, as I mentioned, one of our clusters is now supporting Kubeflow and Spark, and has the GPUs as well. And this is also fully managed, so make it a lot easier for us to just focus on the software we're deploying into it. And studies have shown that these tools deliver twice the value of the initial business case. That was 2021. Interested to know if that still holds. But the ability to build all these models using the data of all the missions is really bringing us a wealth of information to the operators to aid in their decision making. And a number of the projects which we have developed have really taken off and are being used operationally, also powered by this cluster, allowing operators to be able to say, well, we've seen this anomaly, has this happened before, and to get access to all that wealth of information that we have very, very quickly is super useful. So yeah, our platform services here are helping us to also defragment our data services. We have here whole loads of different data services, and the ability to be able to bring all of this together is really fundamental to be able to make use of all that data that we have in order to help build these services that we're now building on top. And using these products, we can then help us to aid us in anomaly detection, orbit determination, and satellite health monitoring and forecasting. So that went a lot faster than I was expecting. Yeah, so in summary, ESA is flying some unique missions. We're de-risking new technologies. We're supporting industry. Our new on-prem platform here is helping us support more missions while reducing the overheads. That was us for key, to be able to bring the costs down, but while supporting even more. And our platform is also now supporting these next generation AI-based tools. So we've really moved on from the very easy days, as it were, of just being able to take the server, put them in the rack, and look after them, to now having all of these services on-prem. And it's been really exciting to be part of seeing that develop over the last few years. Yeah, thank you very much for your attention. I guess there's any questions?
Yes, go ahead. First of all, round of applause. Thank you. Any questions for Michael?
The anomaly detection, is that an off-the-shelf product you're using, or is that something you developed in-house?
Oh, that's a good question. The anomaly detection. I believe it is being developed by a partner of ours. I don't think it's off the shelf, but yeah, I don't know, I'm afraid.
Hello. What kind of equipment, software, and hardware do you use in space? Windows, Android.
Well, yeah, I'm working in SOG, so on the ground. So that's my area of expertise. In fact, I've always been interested in IT. For me, the fact this is in space is the icing on the cake. But that's always been. But I know, I've heard so many different stories from colleagues and so on. There was a satellite actually called OPSAT that ended last year. There's going to be another one, but that was a great project. It was only a 2-unit high CubeSat, but that was actually the first time running as much of normal commercial stuff that you can get in a CubeSat. So it had like SD cards. I think it had, for the first time, quite a powerful for space processor, so an 800 megahertz ARM-based processor, which, yeah, space is really harsh. The SD card at the end was destroyed from radiation, so we had very limited options what we could do at the end. But that was a great testbed for new ideas that people could actually just come up with ideas and actually run them on this spacecraft. But so there will be a sequel. You have to look out for the OPSAT.
For the infrastructure itself, how do you do some sort of continuous monitoring, security monitoring of the whole infrastructure at the same time maintain consistent security configurations across your infra?
Oh, so the question was how we.
Yeah, how do you have consistent, continuous security monitoring?
Continuous security monitoring, yeah.
Of the infrastructure itself. That's one. And secondly is, how do you have a consistent across the infrastructure. Since you're having Kubernetes infra, multiple clusters here and there,
I mean, we have a unit which is actively monitoring for any kind of cybersecurity attacks which might happen. And this is the infrastructure for the operations is anyway protected. You can't get to it from the outside anyway. So that there is that, but nevertheless, security is very high requirement. We have very high requirements for these products that they have to meet. And we're going through that cycle right now for this new infrastructure to try and get that certification such that it's, and for example, that we get patches timely. We just had the recent case for, I think it was the Ingress controller, and that's now just been patched. We had a super high vulnerability, and that's now rolled out. Does that answer the question? Or? Yeah.
Go ahead. I think we even have a microphone. Look at that.
Thank you very much. Sounds like you are running mostly on air-gapped systems. Do you run LTS, and how do you manage updates? You alluded to that, but if you can share a bit more details there.
It's kind of air-gapped. We for the updates in that network, we're using a private cloud repository, and from there we can get the updates, so we can get all the patches delivered to this. So they're allowed to have connections only to this cluster providing these updates, and that's it. And then we can make sure that they're still patched.
The other question, otherwise I'll ask a quick one. You mentioned Kafka, Kubeflow. Are these all working with Canonical as well, or?
Yes, we also had Postgres and Kafka. Yeah, it's the base for our mission control system. Yes, the infrastructure for that is being done with Canonical at the moment as well. So that's ongoing as we speak.
And how did you find going from working on the application and the infrastructure side, the OS and infrastructure side to the application?
Sorry, see?
How do you find working from the OS and infrastructure side to the application? What brought you in that direction? Like, most people are not necessarily used to working with Canonical for applications like Postgres, like Kafka.
Okay. I mean, when we started out, as I mentioned in the presentation, when we started out this journey, we looked at, we want to try and do this support in-house. It was like, well, we're only a small team, we don't have all the expertise in managing this. I was concerned about the day two operations. So how do you keep this going? How do you maintain it? How do you keep it running? And that's when it's like, well, it makes no sense to try and do this ourselves with our small team. We should go on the lookout for an industry partner that can help support us with this. So,
brilliant. Right. No. We have time for more questions. No worries.
Sorry, just on the concept of support and then referencing your security controls. How do you manage the risk with bringing a third-party support provider, essentially internal, to manage your support?
On
So with your security controls being air-gapped, you've got a third-party support provider in Canonical, and how are you able to bring them internally, and how do you manage that risk?
So the Canonical actually have just support, they can only access the machines that they are managing, and only from a specific network, and it's segregated, so they can access in this way. And of course we have checks in place, and we have requirements that you have done background checks and so on and so forth, and that it's in countries that we are okay with, and yeah, obviously we can still be able to see who does what when through all of our access controls. So.
I'm checking if we have online questions. I'm not playing with my phones. Just in case anyone was wondering what the hell they're doing there. Do not believe we have any online question. Any last questions? Otherwise, what we'll do is we'll go for a quick break, and then in about 15, 20, 25 minutes or so, we'll get started again. Once again, Michael, thank you.
walk into a stadium and suddenly you're with 10, 12,000 people and you just feel part of something going on and you get captured up with the emotion and the flow of the game. Today, you're connected all the time, and I think technology has really enabled that. I'm John, and I'm a huge Watford fan.
Hello.
Hello, sweetheart.
Come in.
Nice to see you.
Nice to see you.
My dad went to his first game in 1947 when he was 12, and he took me to my first game in 1977 when I was 12 also.
Along with going to support Watford, I think it's more about spending time with my dad and my granddad and all the people that sit around us.
So how are we going to do?
I'm hopeful because I feel like you've got to have a positive
That's all we can be when you're Watford.
But, yeah, we'll see.
I love being part of the Watford fan community. That's what really football's about. It's really about community. For as long as I can remember, it was almost impossible to upload and share videos for the stadium. But now in recent weeks, they've introduced 5G and it is allowing me to connect with my fan group around the world as if they were there in the stadium with us.
I think we better go.
Ready? Don't forget my scarf.
Come on, Watford.
Right.
There's 22,200 seats in this stadium. A few hours till kick-off yet.
Canonical is a technology company and the publisher of Ubuntu, which is the widest distributed Linux operating system. What we offer is a selection of software that is secure, reliable, and open source.
I am very happy to be here and bringing the benefits of 5G to large venues like the Watford Stadium using our open source technologies.
For the last 2 decades, we've been working to make open source accessible to the widest possible audience. And we are so proud to be doing this work with the BT Group, who are the leaders in the industry.
Since we've engaged Canonical, we've moved from a customer supplier to actually a partnership, and we work really, really closely with Canonical. As telecoms becomes more cloud-based, particularly 5G, which is actually based on a cloud-based standards, BT's had to develop an infrastructure to support this capability. Hence, we've been working with Canonical to develop that. And that, in conjunction with our IP core and our radio access network, allows us to provision 5G services for EE.
Oh, Dad, they've done the team. I'm just going to go and have a look. Have I got any winners? Well, hopefully Watford are a winner today.
Sometimes I'll see like my friend's story and I'll be like, oh, I didn't know you were a Watford supporter, you were at the game, and then we'll meet up, which is always really nice.
You're going to get Liv?
Yeah, I'm just going to text her to meet us by the statue.
I'm actually in chat groups and also then dialing into a podcast, big community of fans calling in, talking about the game. We can share photos.
We send it to Mum and we send it to Auntie Ali? Yeah?
Go for
Okay.
it.
I used to think it was just me that didn't have a signal, but it seemed like no one did. A recent game suddenly went, oh, what's happened? I can call you. And then I found out about the 5G upgrade.
Throughout our partnership, BT Group gains economies of scale, rolling out secure data centers on demand.
Working with Canonical has really enabled us to bring the power of open source software as we converge more and more of our services onto cloud infrastructure.
Come on.
In the last year, we've moved the entire mobile base for EE onto this infrastructure. So if you're on EE, you're on Canonical. One of the key benefits of 5G is it brings increased capability and coverage to high density areas. And what higher density area could you have than a football stadium where you get tens of thousands of supporters congregating in such a small space every weekend?
5G now allows me to do something I could never do before, which is to share instantaneously videos of me with my dad at a game, and I can share that with my family immediately. It's a game changer for us.
It's brilliant that Watford have recognised the importance of match day connectivity to their fans, and it's fantastic that we at EE have been able to work with Watford to provide 5G capability underpinned by Canonical software.
So unlucky. He should have scored again. Disappointing, but never mind. No, everybody's saying the same. Next time, next game. Good game, though.
No, it was.
Deploying your private cloud can be a daunting task. In most cases, it involves configuring and provisioning several complex components. It can cause headaches for even experienced infrastructure engineers. But what if it doesn't have to be that way? What if you could deploy your own cloud in minutes with just one simple command? This is exactly what microcloud is for. Microclouds are low-touch clouds optimized for easy and repeatable remote deployments. Whether you need a small-scale private cloud at the back of your office or thousands of them across your edge infrastructure, microcloud is the right choice. All you need is one Ubuntu-powered system to get started. But don't let the name fool you. While microclouds start small, they can easily scale as your needs change to up to 50 nodes. Microcloud combines best-of-breed open-source components into a lightweight, performant, and secure cloud platform that can run even on minimal hardware. All microcloud components are packaged using snaps, providing an extra layer of isolation, while making sure that updating them is a trivial task. To deploy your first microcloud, run microcloud init. If you'd like to include more than one system, run microcloud join on the other members. Now you can follow the few simple prompts asking you to choose the servers, networks, and storage you would like to include. All the configuration will happen automatically in the background. You can go from having a few servers to having a fully functional cloud ready to run workloads in minutes. And the best part is, microclouds are not only easy to deploy, but easy to operate and maintain as well, saving you time to spend on what brings value to your business. Don't just take our word for it. See how fast you can set up your microcloud. Learn more at canonical.com/microcloud. Open source projects engage thousands of contributors who develop software that is used by millions. These development ecosystems are transparent by design, but also highly fragmented, making security vulnerabilities and dependencies difficult to trace and maintain. 96% of enterprise codebases contain open source, and according to research, 84% of these codebases have at least one vulnerability. Organizations need a secure way to consume open source software. For years, Canonical has shipped regular Ubuntu LTS releases with 5 years of security maintenance commitment for the operating system. Ubuntu Pro is a service on top of Ubuntu that expands this commitment to 10 years and gives you security patching coverage for the operating system, the underlying infrastructure, and the most widely used open source applications. For system administrators, it means 10 years of peace of mind and stability for infrastructure. For developers, it means they can stop chasing upstream security updates themselves and instead pull all their software from a trusted source. And for CIOs, it means visibility and compliance. Ubuntu Pro includes Landscape, which automates security patching and configurations across your estate, and Canonical Live Patch to patch high and critical CVEs in the kernel at runtime with rollout control. Compliance and hardening features like FIPS, DISASTIG, and CIS are also included. It's a comprehensive subscription that securely provides the best of open source, free for personal use in up to 5 machines, and offered at transparent pricing for enterprises. Get started at ubuntu.com/pro.
3 minutes. We're getting started in 3 minutes. Everyone, can I ask everyone to come and sit down? Oh, switching off the music, that's the way to go. Everyone settle down, get a last drink, put their glass aside, whatever you need to do. Right. This part of the presentation is going to be a lot more orange on stage. So I hope you have your sunglasses on, if that irritates. Let everyone in the back, can I come back? Perfect, good to go. All right. By the way, I didn't introduce myself. I'm Thibaut. I run the marketing team at Canonical. You can still talk tech with me, no worries. Not one of these joking earlier on about Cray computers, and that's how I started my programming. So, my programming days, so I've done enough. Don't look at my code; it was terrible, even though it's all online. All right. First of all, I wanted to thank all our presenters from BT and ESA, both for their presentation, but also for being such great partners in this journey to open source. And the reason I mention this is because I quite like to kind of summarize a little bit what I've heard. The first thing I've heard is like one of the great quotes on the BT slides is about the marginal cost of bandwidth, which really is a nice way to say, in an ideal world, we'd like to be able to offer more bandwidth, aka have a lot more compute and networking, but pay a lot less as things go, which is the dream for everyone. And you need to kind of, to make that dream happen, you really need to think things differently. And I think that's what they did. They thought differently about their relationship with their vendors. They thought differently about how they build all their infrastructure in a more kind of composable way. And they looked at open source as the way to effectively deal with things as opposed to all proprietary software. And that has been key to making that cost equation possible, because for a lot of people it is impossible. Like, you can't have more resources, need more resources, and deliver more with less, in a sense. Super hard. The key for that is operations. Both the automation, but also what we heard from both presentations is the importance of standardization. Standardizing your stack across, whether it's your data center, edge, and the effect that this can have on cost afterwards. And finally, I think what we heard, probably not as loud, but security and compliance, and the fact that this actually wasn't such a problem. I love your answer. It was like, hey, what is the compliance problem that you've had with all these open source? And like, yeah, actually, it was not such a big deal. It is a big deal. It's a lot of work to be so cool and run such use networks, space operation, and still look so cool. But in the end, that wasn't such a problem. And the reason I mentioned that is because at Canonical, what we've done, what a lot of people know us for, is Ubuntu, making easy to consume open source. And I think what we showcased in here today is exactly that. If you're not entirely familiar with Canonical, let's give us all a bit of a reminder. It worked earlier on.
Open source is all around us. Whenever you drive, shop, stream, call your friends and family, or look into the depths of the universe, you use open source in some form. But while it plays a key role in our day-to-day lives, open source isn't always easy to use. In fact, for most of its history, open source has lived in the domain of experts. That's why we started Canonical, to make open source easy for everyone. Back in 2004, we created a user-friendly Linux OS called Ubuntu. Today, it's the most popular Linux distribution, with users that range from startups to governments to Fortune 500 companies. In fact, any service you use online today has likely touched a machine that's running Ubuntu. Today, Canonical extends the principles behind Ubuntu to a wider portfolio of open source products. Our reach spans from the smallest devices to the largest clouds, and from the kernel to data-intensive systems. Whether you're developing AI models for self-driving cars, building next-generation telco networks, or critical infrastructure for financial services, Canonical technology enables you to build products at speed and with confidence, and operate software at scale. Working closely with the open source community, we deliver trusted open source for everyone.
There you go. Now, one question we have is, obviously, we're here to talk infrastructure. Who would say, and this is any analysts that you're going to see today will give you more or less this number here. 2025, for one reason or another, I said one or another, I'm sure I can find a second one, but yes, I'm sure you have a bunch of reasons in your head. 80% of companies are out there looking for alternatives. And I'd like to do a bit of a hands up in the room, because frankly, we need to do things a bit interactively here. Who would say that you are currently out there looking at your options when it comes to infrastructure? There you go. More or less 80%. And if you're online, feel free to vote as well. Now, this week is the week of KubeCon. I'm sure you're all aware of that. If you're not going there, I'm sure you have heard of it. And frankly, I don't know who's been to KubeCon lately, but you go there and it's like a toy shop. You're like, ooh, new project here is incubating, new thing there. It's like, how this is the new way you're going to run your container. No, this is the new way you run your VM on top of your container. And you arrive there and it's like, wow. What is really going to work and what is not going to work? What's going to be here long term? What is just here fat for this KubeCon and not the next KubeCon? I'm sure you've all experienced that in one way or another. And what we thought we'd do here today is give you a bit of a view from Canonical's perspective as to where things are heading from an infrastructure standpoint. On this note, I wanted to kind of highlight the fact that we have all our infrastructure product manager more or less in the room. So I'd like all of them to kind of like wave. So if you look around, you have our storage product manager over there, that's Seth. Then mass product manager over there, and then you have our next two presenters, but they'll introduce themselves. So if you want to have any question on the topic, they'll cover it. Why am I mentioning this? Because I think that's the journey that we wanted to kind of talk through today. You've actually heard Isa talk about going from traditional to virtualized. So all of you have spent a lot of time in the last 10 years moving things to the cloud, where the cloud really means public cloud. And suddenly it's like, hey, you know what, like that's good, but there's loads of other options. We've heard BT talk about edge and what do we want to do at the edge. We talk about running Kubernetes at Canonical. We talk about running Kubernetes all the way to devices. Devices being any of the things that surround us here. And so this is the future. We believe that's the way where things are going, to not just run the cloud or virtualize, but have clouds existing everywhere. On this note, we have Titus and Mjona, who will explain all of this much better than I will. Titus, the floor is yours.
Thanks, Thibaut. So let me start with like a short experiment. So please raise your hands up if you are going to KubeCon this week, starting from tomorrow. See, like a lot of people are going to KubeCon. I love this type of events. I love this type of events because I'm always impressed with like how quickly the world around us changes, evolves, transforms. And I have a feeling that every year the pace of this evolution, the pace of this transformation is faster. This might be a personal thing. I'm getting older, right? So things start accelerating. But I think the world around us accelerates as well. And this obviously creates a challenge on all of you who are managing infrastructure in your companies, in your organizations, because the infrastructure has to evolve, it has to transform, to keep up with all the latest trends that we're seeing in the market. So that's what I'm going to talk a little bit more in this presentation, which is like how you can transform with open source, how you can transform your infrastructure with open source. So why is this topic important? Let me start with showing some numbers with you. So according to the latest research report that was put together by IDC, that we also participated in, 7 out of 10 organizations agree that open source is extremely important to run mission-critical workloads. And let me use this opportunity to run another experiment. So please raise your hands up if you're already using open source anywhere in your organization, not just on the infrastructure space, but also the application space, right? Like, everyone's using open source. Everyone's using open source. And trust us, in every commercial project that we run, there's an element of open source that already exists there, right? Like, there's always like this one machine that runs on Ubuntu somewhere, either on a public cloud or somewhere in a data center. Open source is everywhere, everywhere around us. So there's obviously a very valid reason for that, right? Like, so if you look at those stats from exactly the same report by IDC, 44% of the respondents said that open source helps them to lower costs. There's no surprise here. Open source software is free of charge. There are no proprietary licenses that need to be attached. There's no hidden costs, like everything is transparent. So at the end of the day, it helps organizations to lower costs. But there's also another very valid reasons, right? Like development velocity. If you imagine like all of those open source communities grouping together, we've got a representation from the Open Infra Foundation here with us today, right? Like unifying thousands of developers, hundreds of companies, united under like one clear goal, one clear mission. Imagine what power such a big development community can bring to the world. It helps this software to evolve at way faster pace compared to any proprietary solutions. And customizability, last but not least, is also a very important thing. So given that open source software is open, right? Like everyone can take a look into how this code is actually structured. Everyone can make changes there. Everyone can customize it according to their needs. Possibilities are unlimited. Everyone can use it the way they want it. So this obviously comes with a challenge, as you could hear during the opening video, is that for years, open source has been a domain of experts. And taming open source and taming like all of those different open source projects coming from different communities and tying it and making it into something that's more like a solution, more like a product that can be used to power like leading production environments on the world, like big public clouds, requires like another step. And this is exactly what Canonical mission has always been and continues to be and will ever be, which is to amplify the global impact of open source by making it secure, reliable, and available to all at scale. This mission spans across the entire spectrum of open source. It obviously starts with the operating system. You likely know us very well from the Ubuntu operating system, but this mission goes way beyond just Ubuntu. It goes through all of the layers of the infrastructure, so traditional virtualization layer, assembling the best-in-class open source virtualization stack to run your workloads. It goes through the containerization layer. In fact, containerization is a sort of virtualization, if you think about it. It goes up to infrastructure management, so providing all the capabilities for organizations to automate their infrastructure processes, to transition networking from appliances to software, to transition storage from appliances to software, to enable on-demand access to resources requires going through yet another layer of the stack. And all of that spans up to applications, because at the end of the day, what matters from your end user's point of view is the application that runs on top of this whole infrastructure. Our mission also spans across the entire spectrum of compute, starting with public clouds, which is something that I guess most of you are using in some use cases at least, but it also goes down to traditional data centers, the edge that is expected to be bigger than public clouds in the following years. It goes down to the IoT with billions or trillions of interconnected devices in the future, and it goes to the desktop, which serves as an interface to all of those other areas of compute. So the mission to amplify open source software spans across all layers, the entire spectrum of compute that we are seeing. Now, when it comes to building an infrastructure with open source, obviously everything starts on the hardware layer. So our mission is to cover all the leading CPU architectures that we see being available on the market. But obviously these days, this goes way beyond just a traditional CPU. Because in all kinds of compute-intensive workloads, for example, sophisticated AI/ML workloads, we see a growing demand for GPUs. And this includes working with partners like NVIDIA or any other companies who are very much present in this game to provide the best-in-class software to enable this kind of capabilities on top of the open source infrastructure that we provide. But this also goes down into new accelerator type of devices, such as DPUs or data processing units, to enable customers to offload some functions of the cloud to those type of devices, such as networking functions or storage functions, encryption, these kind of things. And this kind of a triangle is likely how the future of data center is going to look like. We've passed the CPU phase. We're now expanding compute capabilities into new types of infrastructure, into new type of devices. This is likely how this triangle is likely going to shape the future of data centers in the following years. On the software side, we take a slightly different approach, because if you look around, like the entire spectrum of open source, it's obviously coming from different communities. Sometimes some of the technologies kind of compete with each other, right? Like they provide exactly the same capabilities. So we take a holistic view across all open source, and we select open source projects that provide the best capabilities in their own domain. So it's like choosing the best of breed software across the entire spectrum of open source and providing that, making it available as solutions with an opinionated design, secure, supported for 12 years, and available with the operations code around them. Because let's be frank, starting with an open source, getting it up and running, getting an open source infrastructure up and running is usually just the beginning of a journey, right? Like the real journey starts once you've passed the initial deployment phase. This whole thing has to be operated later on. So providing the operations code in a form of software packages around the solution is a critical thing. Now, going beyond that, any open source software that exists on the planet, we are committed to make it available in a form of secure, optimized containers, also supported for 12 years on all leading Kubernetes distributions. Now, in some of the cases, open source might not be enough. There are some proprietary solutions that do not necessarily have their equivalent in the open source space. And for those, we're working with leading independent software vendors on the planet to integrate their software with the open source stack that we provide as an integrated, tested, jointly validated part of the solution. So speaking about how you can build an infrastructure with open source, tying it to the slide that Thibaut was presenting before, we have all passed through like the traditional and virtualization phase, right? Like the data center has evolved since then towards something that's fully automated, not just for the initial deployments, but also low-touch operations, something that provides on-demand provisioning capabilities for bare metal machines, and something that's programmable through APIs and that is compatible with the infrastructure as code pattern. Basically, the infrastructure has already evolved from traditional and virtualized infrastructure into a fully cloudified infrastructure, basically expanding public cloud capabilities back on-prem, something that resembles the behavior of leading public clouds. This is how every newly built data center on the planet should look like, because we know very well from public clouds that they provide the best-in-class service when it comes to running workloads on the top, because everything is available on demand, everything is fully automated, everything is programmable through APIs. On the same note, the storage has evolved in exactly the same way. So in all of those traditional data center, we've seen like all of those costly storage appliances that were very much optimized for performance, that were very much optimized for various certain functions. All of those patterns have now are shifting from hardware to software. It's exactly the same thing on the networking side, where the operations logic is no longer implemented in hardware, but is now implemented in software instead. This also helps those storage solutions to be way more scalable and provide a better total cost of ownership, as this infrastructure can be built on top of the hardware that is not as expensive as it used to be, but instead can be implemented on top of a commodity hardware that we typically use in a cloud. Now, the most important thing is that the workload has to evolve in the same way as infrastructure and storage has already evolved. Because if you think about that, we all started with legacy types of workloads that were implemented based on the pattern, so that was just like one big monolithic piece of a software running on top of bare metal machines. A lot of those workloads have been virtualized over time. They have been put on top of virtual machines, but the underlying software has never been re-architected. It's exactly the same software, but now running inside of a VM instead of running on top of a physical hardware. The goal should really be, when you consider moving forward with transforming your data center, to get to a point where the workload is at least cloud ready, meaning that it is designed to be provisioned and terminated on demand, while keeping the cloud native goal like as a long-term objective for your organization. Because this is clearly how the future is going to look like. Now, how do all of those things come together? So consider you're responsible for a greenfield project, and your objective is to build an infrastructure for like the next generation workload. So with all of what we've already said, with the future being fully cloud native, this is how your stack is eventually going to look like. So you're going to run a bunch of hardware, and you would expect to run a bunch of containers on top. All of that can obviously be powered by just those two layers. So the operating system and the layer providing virtualization, networking, and storage capabilities. Obviously, to enable full automation and on-demand resource management capabilities, you would need a sort of a container as a service platform running on top of all of that, providing those capabilities. But let's stop for a second. This is not how a typical real-life scenario looks like. Why? Well, because you usually inherit a lot of traditional workloads too, right? You inherit like all of those Exchange servers, Active Directories, right? Like these kind of machines, SAP HANAs, right? Like running on top of virtual machines. So this is really how a real-life scenario looks like. Yes, for everything new, for everything greenfield, we would be considering turning into fully cloud native, but the reality is that the spectrum, the application spectrum today is a mix of cloud native and traditional workloads. In order to be able to power those workloads, you need the same two layers of operating system, virtualization, networking, and storage, but again, to enable automation and on-demand provisioning and management capabilities, you need a traditional infrastructure as a service layer. The good thing is that those two things, even though historically used to be considered as two disjoint things, have evolved and can now be available under a single platform. So you can get infrastructure as a service layer running on top of the operating system and the virtualization layer with an expandable container as a service layer running on top. At the same time, it is important to mention that the cloud management software itself can also be shipped in a fully cloud-native way, if you think about that. Because the infrastructure as a service layer is nothing else but the software. Yes, it is a software that deals with the underlying hardware, but on its own, it can still be shipped using the cloud-native principle. So if we're shooting for the future, if we're shooting for where the world is heading, this layer does also need to be deployed and operated in a fully cloud-native way. So it's a cloud-native infrastructure as a service with an expandable container as a service running on a single platform, enabling tenants to provision Kubernetes clusters on top of the infrastructure and terminate them when they no longer need them, which also works well in terms of like resource resource consumption and optimization in your data center allows you to run workloads on the top. At some point, you might want to introduce yet another layer of the whole stack, which is hardware automation layer, because manually provisioning several machines is not a challenge, right? But once you scale out, once you grow, once you scale out your infrastructure across like tens or hundreds of physical machines, there's definitely a need to automate all of those provisioning processes. How do you boot machines in a data center? How do you install them? How do you customize the operating system during the installation? How do you configure them post-deployment? All of that needs to be addressed. So there is a need for the hardware automation layer, clearly. And obviously, in big production environments, there's also a need for another two components, which are like observability, how do you monitor the entire platform, and the system management layer that helps you to apply system updates automatically at scale. Obviously, those two also have to run somewhere, but the good thing is that you can use exactly the same platform to put those support functions on and basically standardize on open source everywhere. Now, if we try to map that out into canonical solutions, this is exactly how we approach that from like the solution level, right? Like, so we identify all of those necessary functions in your data center, and then we take like a holistic view across the entire spectrum of open source, and we pick up the technologies that help you achieve those functions and make those available with the operations code, with security updates, in a self-deployable way. So if we go back to this slide for a second now, the set of technologies that I've been showing helps you address the data center and the edge use case. So this is something that you can use to fully build like those two layers of the infrastructure. But we've been saying that we're shooting for the future where all of the workloads are going to be cloud native eventually. So if you think about that now, and if you tie it back to Canonical's mission of amplifying open source, the goal here is really to provide a true multi-cloud experience with the operating system that's optimized to run across all of the layers of the infrastructure, across the entire spectrum of infrastructure, from public clouds through data center to the edge, IoT, and desktop, provide a true multi-cloud Kubernetes that is eventually serving as a container as a service platform that allows you to run workloads, again, across all of those areas of an infrastructure, and a portfolio of multi-cloud applications that can effectively be run on top of all of this infrastructure. We do not do all of that ourselves. We do that with the help of partners. And as I was talking about the hardware, we work with leading silicon and hardware vendors, one of them being Ampere. So by the way, if we're going to have like a round of demos after this presentation, so you are very much welcome to go around and see. We've got like some fresh new Ampere servers, so you're welcome to see how we play with those. But this also goes with our partnership with leading public clouds to make sure that the operating system that we produce, Ubuntu, as well as Kubernetes platforms that they are using, are optimized to deliver a frictionless experience, regardless of whether you run your operating system in a cloud or in a data center, on your end device, or in IoT space. The same applies to the leading global system integrators as well as channel partners. And we are constantly expanding the portfolio of partners that we are working on. So on that note, I'm going to hand it over to my colleague, Miona, who's going to talk a little bit more about services.
Thank you, Titus. Are we audible? We are. Great. So while Titus has been talking about what we do on the infrastructure side, I wanted to focus a little bit more on how we are doing these things, how we are partnering with our customers, with our users, with our partners in order to truly build the future together. So let's say we've convinced you. You might already be using some open source, but you like what you're hearing and you want to use more open source in your infrastructure. Where do you get started? Because there is a myriad of open source solutions out there. Some are developed by very small, passionate communities. Others are developed by slightly larger, passionate organizations like Canonical. So how do you decide which one is the right fit for what you need to do? Obviously, choosing solutions that have the right functionalities is a given. You should be thinking about whether they are doing what you need them to do. But beyond that, you should also be thinking about, for example, whether these solutions are supported and for how long, whether they are compliant with local regulations. You should be thinking about as well, how do they fit in with your existing ecosystem of things. And you should be thinking about where can you get the right expertise in order to manage these solutions effectively. Well, the good news is that Canonical does that on a day-to-day basis. We are not just developing great open source software, we are also working with our customers every step of the way in order to build solutions that are answering your own unique challenges, no matter what they are. Ooh. We've heard from two of our partners. I won't be recapping yet again what they have said, but as you've seen, no matter whether it's about keeping UK connected or making sure that there are satellites in space that are safely operating, we have solved some interesting challenges together with our customers. In order to illustrate these things better, I did want to give a couple of more examples, just so you can see kind of the breadth of things that we typically work with, and also all the different verticals and industries where our infrastructure solutions are being used. So first up, we have none other than the United Nations. And as you can imagine, for an organization like United Nations, they're processing and storing quite a lot of really sensitive and confidential data. Because of this, they didn't want to use any of the commercial cloud vendors, but rather they wanted to build their own private cloud based on open source solutions that they can customize according to their own specific needs. As a result, they have a secure sovereign cloud based on open source solution that they have complete ownership over, where they can make sure that the data that they're working with is truly safe and secure, and that nothing gets out where it's not supposed to be. A slightly different use case is SBI, which is a financial services operator from Japan. They had an issue because they really wanted to modernize. They wanted to transition from traditional virtualization to OpenStack, but they needed to do it in a way that would allow them to avoid business disruption at all costs. This was a little bit difficult because some of their legacy workloads were not suitable for migration. They approached many different vendors. At the end, they spoke to us, we discussed various options, and we then decided to help them build their modern cloud based on open source solutions. As a result, they had seamless migration of their critical environment, but also they were able to receive support for some of their legacy workloads that couldn't be migrated from us, and then reduce time to overall deployment. On the other side of the globe, we have University of Ontario, the French campus. It is a new university that just started a couple of years ago. They have a small campus with a couple of hundred students, but they have big plans for growth. They are planning to grow both the number of students that are at the university, but also they plan to expand on new campuses as well. And their main problem was that they had 2 people in their infrastructure team. And these 2 people had to kind of maintain all the infrastructure that they have, their cloud, their internal systems, the research resources that students are using. And again, they came to us, we discussed options, and we chose microcloud as one of the solutions. As a result, they had full backwards compatibility with their existing infrastructure. They got support and professional services from us. But now they are able to maintain their cloud infrastructure and to scale it very easily as they're growing and as they're opening new locations. We have another university in our portfolio that had slightly different challenge. They're a national research institute that does quite a lot of computationally heavy things across many different fields. They were doing fine, but they wanted to modernize because they saw that containerization could help them accelerate their research outcomes. They had a variety of ideas. Again, they spoke to us. They wanted to go with OpenStack. Then they decided to go with a couple of other things. And the main reason they decided to do this together with Canonical is because they thought that our solutions stack very well together. You can use them individually, but then you can also combine them into one larger things that works seamlessly together. And as a result, they have now a modernized data center. They can leverage prepackaged applications with Kubernetes. And they were able to build an easy self-service for their researchers, which saved quite a lot of operations time. I have two more, and then I will talk about other things. So don't worry, I won't just be going like this for the rest of the presentation. So next up is One Uptime. It is a software platform that help you analyze causes of your downtime, incidents, monitoring, things like that. Their main concern were costs. They were running things in the public cloud. The costs were getting higher, and they wanted to try to reduce costs by transitioning over to bare metal infrastructure. Again, they worked with us. They built their new cloud, and as a result, they have more than $350,000 a year in savings, which might not sound as much, but for them, it's more than 75% of their total cloud costs. So it allowed them to save money while at the same time having a fast, high-performant, and secure cloud that can host the services their customers are using. And this is the last one. It is Italy's National Institute of Geophysics and Volcanology. So they are running multiple monitoring services that are monitoring earthquakes and volcanoes. And their main concern was truly business resilience. They wanted to make sure that their monitoring services are available from anywhere, and that in case one of their locations gets jeopardized or something happens, another one can take over. Interesting thing when it comes to this specific use case is that they are not going to stop with just one cloud. They will likely build a few more. And they worked with Canonical to design this first one, but then we were able to provide them with a blueprint based on the first implementation that then allows them to upskill and to build further clouds themselves. So as you have seen, we have worked with customers across verticals, across industries, in order to build solutions that are solving their own challenges. The way we see it is that you have your own unique expertise in your domain. We have expertise in open source, and then when we put these two things together, we can truly make something that really does the job and that makes sure that your infrastructure is ready for the future. And when I say across challenges, I truly mean this could be anything. It could be something like migrating from legacy platform onto something new. It could be related to security, compliance, sovereignty, simply if you want to have control over your infrastructure, over your data, not rely on the commercial cloud providers, we can absolutely help you with that. It could be about skill gaps. If you're not sure how to use open source, we can help teach you. It could be about cost, simply, it's expensive to run a big business, so costs, and cost optimization is important. It could simply be about automation. Whatever your challenge is, chances are we've done something similar with some other customer, and then we could do a similar thing with you. So, as we've alluded to and spoke about, and our customers have spoke about, Canonical's aim is not to be just a vendor, but your true partner that will be with you every step of the way. We have a variety of different teams, from teams such as my own, where we develop cool new products. We have professional services team that works on design and delivery, where they would work with you to analyze your specific requirements, to then discuss possible architectures, discuss possible hardware, build the cloud for you, and then also hand it over to you after it's done. In case you would prefer to spend your time on your actual business as opposed to infrastructure operations, we also have a managed services team that can manage the infrastructure for you. We can provide training so that you can slowly get up to speed and then take over the maintenance from us. And then we also provide migration services as well if you are completely migrating from one platform to another. And I do want to just speak a little bit about migration specifically, because as we heard during the beginning of presentation, 80% of you are likely thinking about doing something new. And I think no matter whether you're migrating from a proprietary solution or an open source solution, from public or private, chances are that the migration could be quite complex. It's not only about the workloads and their dependencies, it's also about the variety of tools that you might be using and the variety of functions that you might be needing. So when it comes to migration specifically, we do follow a structured process in order to make sure that everything is done well and that you are set up for success. We would first look into your existing infrastructure. We would analyze them, look into your workloads, look into dependency between them and things like that. And based on the data that we get from that step, we will only then proceed with design and architectural discussions. If the use case is complex, we would likely propose to also do a proof of concept, where we can do a couple of test migrations, make sure that everything is running as intended. We can adjust and optimize, and then fully migrate. We have done this with quite a few customers, so we can definitely discuss your specific needs if this is something you're considering. No matter which product you decide to use or which kind of services you decide to use, our support commitment remains the same. Our goal is really to provide a long-term support for a variety of open source tools you might be consuming. So right now, we support more than 36,000 different open source packages across all the layers we've talked about today. And you can then come to us and get everything you need when it comes to open source. So if there is one thing that I would like you all to take away from today, is that you should be exploring open source more. No matter how much you're using it right now, chances are that you can do something even better, something even more useful. So I would like to invite you all to think about a part of your environment that could benefit from being open source. And then you can come and talk to us about how we can truly build your cloud your way. No matter what your priorities are, whether it's better price performance, whether it's data sovereignty, whether you simply want to have architectural freedom and not worry about, all of the things that when you use a specific proprietary vendor you need to choose, we are there to discuss it with you and make a good plan that will fit your use case. This is all for today. We are reaching the end of the presentation. You can continue the infra journey. So for those of you that are here in the office, as my colleagues have mentioned before, we do have some demos prepared. So there is a boardroom on the left side where we have some hardware. So if you pass there, there will be our experts that can help show some of these solutions in person. We are here all week. We will be at KubeCon as well, as they have said. So if you want to talk about containers specifically, find us there. We can also talk about other things. And then on Thursday evening, we will be having another event here at the office. So if you're liking this space and you would like to see it again, come again on Thursday. And this is all that we prepared for today. This QR code is useful where you can discover more resources. And I think we have some time for Q&A, right?
Yeah.
Yes.
Thank you. Right, so this time I'm going to be roaming around with the microphone. Any questions? I like running around, so if you want to have questions from the back or from the front, it's okay. No questions. That was so clear. All right.
Your migration services that you spoke about, is that like a package service, 5 days, 10 days, or does it change?
Well, it changes because, again, it all depends on what you have in your infrastructure currently. If you have something small, straightforward, with like a small number of VMs, obviously it would take less effort to actually do the migration. Whereas if you have a big data center with thousands of servers and tens of thousands of VMs, it would obviously be something more. We do have a couple of our people that work with professional services. So if you want to discuss some options with them, I can introduce you after and you can see kind of where your use case fits.
Any other question? There you go. Obviously, Phil, do you want to go? Perfect. Thank you.
Thank you. When we consider the public cloud, for example, so there is the concept of the cloud security posture management that as you are building new infrastructures in the public clouds, you tend to see what does the configuration looks like. Is it secured? Where should I be improving? What are the gaps? Are there solutions like that? Or what would be recommended when building a private cloud based on, say, OpenStack?
So I'm not sure what exact capabilities of public clouds are you referring to be able to provide you with a strict answer.
It's more like trying to identify a like for like when we consider the public clouds and the private cloud. So when we provision compute, for example, we tend to see do we have the storage for that specific compute? Is it encrypted by default? What does the configuration looks like when you are configuring your networking? What are the security groups? What do they look like? Is it compliant based on the organization's expected cloud security standard? So are there solutions which are recommended when building private clouds based on OpenStack?
So, well, things differ depending on like the platform that you're using underneath, right? Like as you've seen in those slides that we were presenting, right? Like there's multiple solutions that you can actually put together to build like an infrastructure with open source, right? Like, and there's like various concepts, like from profiles to like we even work with like partners who provide like an overlay layer on top of like private cloud software, things like cloud management platforms, for example, which also provide these capabilities. Well, there's no single answer to that, but yes, things like that exist.
In this particular case, we're using Canonical Charmed OpenStack.
Okay, well then, I need to kind of dig a little bit more deeper into your particular case to understand, right?
But I do want to add that there is a second part to that when it comes to security standards and regulations, which we work really hard to adhere to, whether it's things like SIS hardening, which is usually important for companies here in Europe, or things like FIPS and DSSTIG, which is more important for companies in the US. Our security team works on kind of making sure that all of our infrastructure conforms with those standards so that it's testable. And we also have an automation tool that can do auditing for you. So once you harden your host, it can do the audit to make sure that it's all...
I think my colleague's more addressing ongoing compliance and validation so that you could substantiate that those are in place operationally as you go forward, not just a one-time event during the building of the cloud, which we've seen can be done, but more a holistic approach as part of the cloud lifecycle. Right.
Okay, looks like we have an ongoing work session that we need to set up here. We'll make sure Brianna gets plugged in. Any other questions, or is the call of beers and more prevalent?
I mean, I think as Thibaut has said before, we will be around. So if there's anything specific you would like to discuss, or again, if you want to see the demos in the next room, just pass by and then we can talk more.
I was going to say, do you have a quick description of the demo so that you know what to go and see or not see next door?
Well, when you enter the boardroom, you would actually see like a glass window and then a mini data center right behind it. So in that data center, here in the office, it's running all of our Canonical infrastructure. So you can see microcloud in action, you can see Kubernetes in action. I'm not sure what else they have prepared, but they will tell you as soon as you enter the room. And as Tito said, we also have some new equipment that we want to show off as well.
Brilliant. On this note, not going to delay the beers anymore. I'll let you run. Thank you so lot for your time today. It's been a pleasure. Thank you, our presenters.